Welcome to Autotech Labs. Today we will see how an automotive disc brake system works. Let's see the principle behind the disc brake system. The brake system works based on the Pascal's law. The law states that pressure exerted anywhere in a contained incompressible fluid is distributed equally in all directions throughout the fluid. Let's make it simple. Consider two cylinders with pistons, connected each other, and filled with incompressible fluid. The mathematical relation is as follows. F1, applied force on left piston. F2, received force at right piston. A1 and A2 are surface areas of both pistons. P1 and P2 are pressure experienced by both pistons. Pressure can be stated as force experienced per area. So P1 equals F1 by A1. And P2 equals F2 by A2. According to Pascal's law, pressure on both pistons are equal, which gives us P1 equals P2. So, when force is applied to the left piston, the fluid will transmit the force to the right piston surface. But it will be a factor of the ratio of two piston surfaces. This concludes that, with a small force F1 at left piston, will give a higher force F2 at right piston, provided if A2 is greater than A1. With this, the left piston can act at the pedal side, and the right piston can act at the wheel side, transferring energy from pedal to the brakes. Now we know the theory, let's see how this works in real. Let's see the exploded view of a car wheel, and the parts involved. The wheel hub assembly, the disc brake rotor, the brake caliper assembly, the wheel, and the lug nuts. The wheel hub assembly holds the wheel and the disc rotor, and the bearing inside it allows their smooth rotation. The disc rotor is the part to which the brake pads squeeze against. This will create friction that retards the rotation of the wheel. The disc rotor produces a lot of heat due to this friction, and the drilled holes provides ventilation to remove this heat. The brake caliper assembly uses the hydraulic force from the brake pedal to squeeze the brake pads to the rotor surfaces, thus creating friction, and decelerates the wheel. The caliper assembly consists of the caliper bracket, slider pins, dust boots, inner brake pad, outer brake pad, caliper frame, and inside it, the piston. The caliper frame is having a banjo fitting, through which the fluid will reach till the piston. The pressurized fluid from the pedal side is capable of pushing the piston with great force. Also, the caliper frame is free to slide along the slider pins within the fixed extend. Now we know the parts, let's see how it works. When you apply the brake, the caliper will receive the high-pressure hydraulic fluid from the brake master cylinder. The fluid will push the piston, which makes the inner brake pad to squeeze against the disc rotor surface. As a result, the fluid's backward force will push the caliper frame along the slide pin, which makes the outer brake pad to squeeze against the other side of the disc rotor. Let's see one more time from the top view. The fluid pushes the piston, and the piston pushes the inner brake pad. Once the inner brake pad is pushed against the rotor, the fluid will push the caliper frame. The outer brake pad will now be pulled towards the other side of the disc rotor. This is how the disc brake system works on wheel side. In the next part, we will see what's a master cylinder, and how it transfer fluid to the caliper.